10,000 events, and it doesn't, right? And it's also considered as fast tester. And of course, you know that fast testers can be very powerful in certain contexts, right? Because, as you said, they help you to detect many corner cases that you did not think about. But there are also lots of other problems with fast testers, and we will look into that later. But when we talk about Monkey, we usually refer to automated tools, okay? And obviously, the proper way to say or refer to these tools is automated testing or lead generation tools, okay? But we like Monkey too. So basically, the whole workflow of automated GUI testing is that we have this tool, and we have developers and testers who help us to specify these oracles, or run the tool, and then we run the tool on these applications, and then we detect the problems. Okay? So today we're going to talk a lot about this part, which tools exist here, and we're also going to talk about a lot what we need from developers and testers, what kind of input, and we'll also talk about open challenges which still exist out there. So probably I'm going to repeat some of them, but it's good because if you're going to work in this area, you'll need to motivate your papers, and this will be important for you. Of course, why do we care about automated testing in this domain, right? You may say, well, I have 5 devices, we have small app, right? And we can test it on our own, right? We can just release a new version, we can manually test it. And this is actually what happens in real life. That's what developers actually do nowadays. But to stay in touch with the customer requirements and be competitive, you will be needing to release very fast, okay? And to keep up with that pressure, you need to be hopefully testing your applications automatically. As I said, we have lots of these reviews, and nowadays there is a lot of research how to make them useful. And I'll talk about, towards the end of the talk, about some of the ideas, how we can bring seemingly unrelated things, like reviews, to automatically test your applications to try to see what is mentioned in those reviews. We have to deliver fast, we have to deliver often. Of course, we have fragmentation, as I said. We ideally need to test on all these devices, but practically, it's very difficult. And just to convince you, there is some stats to support that fragmentation does exist, and it's a big problem, and it's not going to go away in the near future. Actually, it's going to be even more pertinent with our Internet of Things revolution happening, right? And manual testing is still preferred method of testing for most of the developers. So these are some of the other challenges developers need to care about: battery, GPS. We use our cell phones everywhere. We dive with them. We bike with them, and we need to make sure that they work in those conditions as well. However, there are additional challenges, like when you test the applications, and these are usually things that you learn by doing, because people don't usually mention that in research papers. Like in this particular case, when it comes to testing Android applications, if you will try to test the same application in a row, if you don't clean, for example, the data in the application, most likely you're going to get different test results. Because the models that you can derive from the application, in some cases, will be based on the data that you already have, right? And the problem of cold clean starts is an important one, because if you especially want to make sure you're comparing apples to apples. There are certain components that are very difficult to deal with when it comes to designing oracles. So I just listed some of these here on the slide, and I want you to think a little bit. What do you think the problems are with these components when it comes to testing? What do you think, what kind of headache can they possibly cause for you as a tester if you have them in your application? There are multiple answers here for each type of component. Some of them are easier than others. So let's say, what's the problem with GUI with time counting? That's an easy one, super easy one. What's the problem here?
Input frequency, maybe. How fast can we input commands?
Yes, this is true for some other. But for input counter, basically here, if you're going to do, for example, as you said, screenshot-based Oracle, then a different value of this counter will basically say this test case fails, right? But when it comes, for example, to time date pickers, if you, for example, run this application on Android virtual device, and there is some lag for you to execute the tap or swipe command, for example, on this particular date or time, you may end up with a different value, right? And the Oracle is going to tell you that this test case fails, right? When it comes to notification grower, these are external events, right? Events coming from other applications or other services. So your Oracle will say that your test case fails because you got some notification from somewhere else, right? And this is a very difficult problem to. This is a very difficult problem to solve, right? With this problem, you can be more generic with specifying Oracle. Here, you also can think about immediate solution, but here it's very difficult to model Oracle for this situation. And we'll talk about some of the solutions towards the end. Additional challenges are backend authentication. You need to provide login and password. There are some privacy-related issues. And of course, a huge challenge on backend services and games. If your application depends on some service, how can you test this application without actually calling that service and getting real response or real data from that service? These are big problems and challenges. And this is actually an example of one of the automated approaches. It's called DroidMate. It comes from Andrea Zeller's group. I think he worked on this several years ago. Looks cool, but seems to me this handles only tabs, right? Although maybe now it also can do other things. But the point is, we hopefully can do better, and hopefully we don't need this kind of sophisticated devices to test our Android applications. So now, let's look into some of these approaches that can help us with this task. So the first very popular tool for testing applications is called record and replay. And record and replay tools, they are not specific only to Android or mobile applications. They've been used prevalently also for desktop applications and web-based applications. And the idea behind these tools is fairly simple. We have a tester, and the tester uses application, and there is some tool in the background which records exact sequence of actions or events that this developer is dealing with. And then it generates a script. And this script can be a set of low-level commands, a set of high-level commands. And the idea here is that once we have this script, ideally we would be able to replay it multiple times when we're developing our application, right? And if, let's say, our GUI does not change much, then these scripts will be useful for us, right? Because we can replay them and we can check them against our Oracle, and again, we're going to pass them to a monkey tool, which is going to check them against Oracle and tell us if there are any problems. And in fact, there are many nice tools out there which help us to do this for Android. So this is one example of the tool, which is called Rerun, comes from University of California researchers. And basically, it can do really nice things like that. Is this Angry Birds? Yeah, it's Angry Birds. So basically what this guy is doing, he's testing Angry Birds, and he's recording, he's already replaying. He's already replaying his script with Rerun. And Rerun can do not only this, they claim that can also do something like that. They call this feature time working. So basically, once you record your events, then they can compress the time in between events and do the rerun much faster. So you see time warp version on the top, right? So this is record and replay tools, okay? And rerun is one of them. So before jumping into pros and cons, so you've seen one of these tools. What do you think are the pros and cons for record and replay tools? Of course, there are many different versions and types, and some tools are better than others. Would you use such a tool?
Person specific, so if you change the amount of thing, you cannot read the script.
Yes. Would you use such a tool? In which context? If yes, in which context? In no? If no, then please justify your answer. It's a pretty cool tool, from what I can say, right? There are pros and cons. You are a test manager. You need to make a decision which tool you're going to use on this project. So you're going through different tools. I just showed you one type. You need to make a decision. Are you going to use it or not?
I think that's good for game development.
It's good. So you would use it. Okay.
Because I'm not able to drive the car so fast.
Okay. Good. Everybody would use it. Can you point out some limitations? Why would you use it? Just give me a convincing reason. Why do you like this?
Maybe to check artifacts on the display if I do the things fast.
Okay, so you want to kind of stress test it, right? With time warping, it's a good idea to stress test. That's what you're saying, right?
Yeah.
Okay, I agree with you, but there is one major reason why some people are using these kind of tools. And there is not an accident I showed you the game. It would be very hard to test Angry Birds with some automation test framework, right? By trying to call APIs. Very hard. Because you don't have objects, classic Android objects that you could interact with by relying on API, right? You have lots of images and sprites and other things on the screen, which would be extremely, extremely hard to test by relying on APIs unless there is some game-specific testing engine that allows you to do that in your internal APIs, right? From my point of view, the major reason why I would use this tool is because it allows me to record exact usage scenario, right? Something that you would actually do on the phone, right? Possibly some very complex scenario, right? And I can replay it. So in other words, when I do changes in the logic of that game, not so much in presentation level, but in the logic of the game, I should have a valid test script, right? So this is a great tool from that point of view. But as Gabriele pointed out, there are some limitations, right? If I change, for example, my loop significantly, well, in this case, if I do some significant changes in the logic in Angry Birds, and it results in some other objects popping up on the screen, then my test case is going to fail, right? So these kind of tools, they would require expensive collection and maintenance, right? Because I have to manually collect this test script, and then in some cases I need to re-record it, right? And remember our fragmentation problem, right? It's a great tool. You will be able to do it on your tablet, but good luck rerunning that on Gabriele's phone. Okay? So the problem here is fair locus. It's coupled to device locations, right? And basically what it means, you will need to record different versions of those scripts for different devices. You need to maintain them, you need to run them, and then you need to maintain them by figuring out if you do some changes, which ones and which devices you need to re-record, etc. So that's what you will be worrying about if you're using this tool, right? But it's a very effective tool for testing real scenarios that you can record. The next type of approach is called model-based testing, and there are many different instances of this approach, and the basic idea here is that we somehow build the model of the application, and there are different ways to do that. And then this model is used by Monkey to choose events to throw at the application to actually do the testing. And the way we build the model, of course, it can be manual, right? We can manually say, these are the components that we have, these are possible transitions. We can also manually build them, but in a tool-assisted way, in the sense that we can have some tool that records your state so that you're just exploring the application. We can have fully automatically generated models, which are based from the source code by relying on static analysis. We can have approaches which rely on dynamic analysis, and these models can be ripped at runtime, so when you run the application. And these models can also be ripped upfront. So in other words, before you actually use the application. There are different ways to actually run these approaches, but first, basically, this shows the idea of how we do that. This is our application, and we take a snapshot of this application. And when I say snapshot, it doesn't mean I take a screenshot, right? In this case, I can, let's say, take some internal snapshot of what is going on inside of my application, right? And then I can use that information to build the model, because at every step, I can see what is different in my snapshot, right? For example, I moved from this object to this object, and I moved through the clip. And that's something that I can revise in my model. And basically, the monkey knows that this is state that I'm in. These are possible transitions from this state, because these are other things I see on the screen. And monkey knows that, okay, from this state, I can go to another state by means of firing this event, right? So this is the idea behind GUI rippers. And the way they usually work, they work in some sort of systematic fashion, either depth first search exploration of the model, or breadth first search exploration of the model. They also can be random, and they also can use some prior knowledge from or have some sort of preference, right? We know that these events happen. Now we can suggest next to them based on this preference. And the way to implement these GUI rippers, there are different ways how you can do that. But the most common ways are to rely either on utilities or APIs or underlying frameworks. So in our research lab, we mostly build these kind of tools by relying on SDK utilities as a hierarchy viewer and UI automator. These are tools that are offered by Android, and I'll show you some examples of those tools. And the great benefit of those tools is that they give you UI hierarchy for every step in the application, which essentially tells you this is what you see on the screen and this is what you don't see on the screen. But these are components which are available at this moment in time in this given activity, right? There are also some pretty neat ways how you can do that also with accessibility services. Actually, I had a class project in my class last semester, and we implemented one of these rippers using accessibility services APIs. But this is the basic idea. We have some implementation of how we can derive this model, and then we use this model in Monkey to help us with testing. So this is a depth first search ripper that we implemented in our lab, and essentially what it does in this demo, it does signal cache application. So first it builds the model of this application. In this case, it rips the GUI at runtime. So at every moment in time, the tool knows this is the state way in. It knows which other objects we can interact with on the screen. And it chooses to go into different states based on the depth first search, so in this case. And it just happens that we found a crash. It's great. I'll talk about that a little bit later. But obviously there are some pros and cons for GUI rippers. These are very popular tools. They do allow us to generate event sequences. They do allow us to explore applications fully automatically, right? And this is great. Technically speaking, it's a zero effort for us, right? We can have completely hands-off, and this GUI ripper will be able to test the application. However, there are some problems here, right? It may generate some invalid sequences. Why do you think it may generate some invalid sequences? The example that I showed you so far did not generate any invalid But why do you think it may generate invalid sequence? A hint. Remember we talked a little bit about the problem with cold starts, having some data in the application. How do you think that may impact the sequences that we're generating? Let me give you a simple example. Let's say you have a to-do application, okay? And let's say you build a model, and at some point you create a new task, right? And you have one item on your to-do list. Okay? But also at some point in that scenario, you remove that item from the to-do list. Okay? So basically at some point you will try to access item on the to-do list, but it may not exist anymore. So here we have the problem with an application state that does not exist due to the data that was delivered, right? So this is a case where our depth first search approach may assume that there are some items in the list, but they are no longer in the list. And it will try to generate event sequence, assuming that there is data in the list. So by no means, this approach is going to give you a complete model of the application, right? Because there will be some data-dependent states. It also will be able to uncover fewer core interfaces potentially. And what is even more important, as you saw in the example which I showed, use case was not really realistic. Yes, it was not as random and as arbitrary as monkey clicking all over the place, but it was not a typical usage scenario that you would do with that application, right? That's not something that you would do by clicking on every checkbox. You would do some meaningful thing with this application. That's a good cash application for managing finances. You would open an account, you would check the balance, you would transfer money. These are meaningful scenarios that you would do. But this is not what usually systematic application tools do in this case. In some cases, it would require manual execution, and as I said, we may end up having incomplete models. And of course, when it comes to rippers, the problem is in many cases there is no context and there is no history awareness, right? So they don't take into account previous states. They just see what is available at any given moment in time, and we go and explore them systematically. Now, let's revisit monkey again, right? And the idea behind monkey is simple, brilliant, and monkey indeed can be very effective in certain contexts. And what it does, it just throws events at the application, and so yes, some of those events will be invalid, but the power of monkey is that it can throw thousands or tens of thousands or hundreds of thousands of events, so eventually we will get maybe to some crash, right? But of course it depends on our application, right? If we have simple applications, monkey is great, right? Because in a few steps, we will get eventually out somewhere, right? But if our application has complex logic, depends on certain inputs, that's going to be the problem for monkey, right? It's going to be the problem for monkey to get beyond the first screen, right? And in fact, it's interesting because monkey has been so widely utilized, not only in software engineering, but also in other fields. For example, I have a colleague who works in the systems area, and he has this project. They're trying to reduce energy in smartphones, and the way they're trying to do that by implementing some really cool ideas at the operating system level. But what is interesting, when it comes to evaluation, they're relying on monkey. And they're relying on monkey to represent how users would actually use applications. And we recently had a fairly extensive discussion with him because he said, oh, my grant proposal was rejected because reviewers said, great idea, but the way you evaluate it, you're not convincing us that we are really observing any savings because the way you design the experiment is sort of confounded. Monkeys are not humans, so these are not real usages, these are not real scenarios, right? I've seen lots of different cases like that where monkeys actually used in other fields as a representative tool, but in fact, in many cases it will not get beyond the first screen. Okay. This is an example of Monkey. It's super easy to run. It will be on a virtual machine I'll share with you. So all you need to do is just launch this terminal, type in this command, and of course install and run this APK of the emulator, and it's going to be doing some magic like that, right? Just throwing events at the application, and eventually maybe it will expose a bug or it will crash an application. And once in a while it will be outside of the scope of the application. This is something that you probably did not intend Monkey to do because you really wanted Monkey to test the application. But as you can see here, it actually got into system properties and wandered away, right? Of course, Monkey is useful, right? Because it's fast and it's good at finding crashes, especially if you have shallow crashes, right? However, it's going to generate lots of invalid events, and it does lack expressiveness. What I mean by expressiveness is if it does find that crash, good luck asking Monkey how do I get to that crash, right? And this is what developers need. They don't need just a screenshot. They need information how to get to that crash. So later on I'll show you some of the solutions how we can do that. Of course, there is a whole slew of automated frameworks where you can rely on APIs to test your applications, and there are some famous ones as JUnit, Espresso, UI Automator, Robotium. So the idea here is that developers and testers supply test scripts. They can be either high-level scripts that rely on APIs, as you write. There are some really cool solutions I'll show you in a second where you actually don't need to write these scripts. You just need to record the script by working with the application, and the tool will automatically translate your actions with the application into the code of these test scripts that you can use to replay. And of course, the good thing is with these frameworks that they are, these test scripts are easy to reproduce. It's high-level syntax that you can understand. In other words, you say, I click on that button with that ID, and it's very easy. It allows black box testing. However, there is obviously a learning curve. You need to learn a specific framework behind that test automation framework. You also need to define oracles, and maintenance may be expensive, because now think about making changes in the application and then going back to your script and making changes in your script, right? So again, this is just a summary of pros and cons for some of these tools. Again, none of these tools is perfect. Some of these tools are better in one context than in another. Some companies use combinations of these tools, but there are lots of developers that use none of these tools, and they mostly rely on manual testing. So this table actually summarizes some of the research prototypes which exist out there. You may have heard about some of these tools. One of the very first tools which sort of became available in this area is Dynadroid from Georgia Tech. They roughly can be classified by different dimensions, like whether they require instrumentation of the application or they don't require instrumentation, whether they support events at the GUI level, system level, whether they support which type of exploration they support, systematic, random, and or recorded replay, whether they're able to generate replayable test cases, or whether they work on emulators, devices, or both. And there are very, very few approaches that actually work on real devices. Okay. Any questions?